Right, the purpose of this video is to take your knowledge about locus to the next level. In particular, we're going to focus on what locus looks like when we take it to the coordinate plane. So let's begin by reviewing just a little bit what a locus is. You should understand from what we did in class today that locus is simply a set of points that meets a certain condition. Or a certain criteria. So as long as the points meet the condition that's given to us, they satisfy our condition and they are our locus of points. So the procedure that you're going to use to find a locus is to start by making a diagram. That diagram will contain the fixed lines or fixed points that are given to you in the problem. And that's kind of an important thing to note because sometimes kids wonder, where do you start or where do I begin? Those are going to be the ones that are given to you in the problem. So that's where you're going to start. You're going to start with what's given to you. Number two, you're going to decide what the condition is that needs to be satisfied. And then you're going to find a point that meets that condition. Once you've found one point that meets that condition, you're going to go locate several others. These points should be in such a way that you can figure out or begin to develop the shape or the nature of what the locus looks like. Is it a point? Is it a line? Is it a circle? And then once you know what the shape of the locus is, then you can use those points to draw a line or a smooth curve, and then describe the locus using an equation or in words. Now today in class we focused on describing in words, but on the coordinate plane we're going to switch our focus into using an equation. All right, so let's see what this might look like. Number one says, what is the locus of points that's equidistant from the lines whose equations are x equals minus 2 and x equals 4. So this is what we're given. That's where we're going to start. That's where we're going to begin. So I'm going to go ahead and start by drawing the lines whose equations are x equals minus 2 and x equals 4. So x equals minus 2, it's going to be this guy right here. X equals 4 is going to be this vertical boy who passes through the x-axis at 4. I'm going to go back and I'm going to add a couple of arrows here just to make my details good. I'm going to label my lines. And now I need to decide what is this condition that needs to be met. Well, the condition that needs to be met is that all my points in my locus have to be equidistant from those two lines that I just graphed. Equidistant, remember, means same distance from one as it is to the other. So I'm going to go simply find one point that's equidistant from each of those two lines. And that point right there is right in the middle. It's 3 units to the left of x equals 4. It's 3 units to the right of x equals negative 2. There's another one that is equidistant, and another one, and another, and another. So my locus now is starting to take shape. And what I'm going to do is I'm going to plot as many of these points as I need to in order to determine what the shape of my locus is. It's pretty clear, it's pretty evident at this point that my locus is going to be a line. I always remember going to sketch my locus by using a dotted line. And then to answer the question says, what is the equation of that locus of points? What is the equation of that line that's equidistant from the two given lines? Well, its equation is x equals 1. So anybody who is on the line x equals 1 meets the criteria or meets the condition of being equidistant from the lines whose equations are x equals minus 2 and x equals 4. All right, the next one says, what is the equation of the locus of points that's equidistant from the lines whose equations are y equals 3x plus 7 and y equals 3x minus 1? Once again, before I get going, it's important for me to identify where exactly I'm starting from. So my starting point here is going to be those two lines. So I'm going to go ahead and begin by putting those guys on the graph. Y equals 3x plus 7 is going to have a slope of 3 and a y-intercept of 7. This guy is going to have a slope of 3 and a y-intercept of negative 1. Now I'm graphing using slope and y-intercept. But if it was easier, you could always make a table of values and graph those lines using your table of values. So I'm going to go find the y-intercept. I'm going to put a dot there. From there, I'm going to go up 3 over 1 in such a way that my line runs uphill. And now that I've got a feel for the way that line is going to look, I'm going to go ahead and I'm going to graph that line. And I'm going to do the same thing for this. This guy's y-intercept is at -1. I still have a slope of 3. I'm going to label these fellows with their equations. So there's my starting point, and that's what I'm given to work with in the very beginning. The condition that I want to satisfy here is I want the set of points that's equidistant from each of those two lines. Well, I know equidistant is going to run right up the middle. So I'm going to go ahead and take a look at their y-intercepts. One was 7, the other was -1. The distance between those 2 points is going to be 8 units. You can count them if you want to. So halfway in between is going to be 4 units from each. So that point right there is going to be equidistant from each line. Now I know that in order to remain equidistant, I'm going to have to run with the same slope that I already established. If I run with anything other than a slope of 3, my locus is going to become closer to one of the two lines than it is to the other. So there's what my locus is going to look like, and now that I've got the gist of what it's going to look like, now I can go ahead and I can sketch it in there. So this guy has the same slope as the originals, but his y-intercept is going to be at y equals 3. So his equation is going to be y equals 3x plus 3. Anybody who's on that line is equidistant from those two given lines. All right, let's go take a look at a different one that doesn't involve a line. This one wants to know what is or are the equations of the locus of points that's 3 units away from y equals 2. All right, I guess I lied. This one does involve a line. Again, I need to think about where I'm starting from. So in order, or if I go back and look in the problem, I'm starting from the line whose equation is y equals 2. So the first thing I'm going to do is I'm going to go get that on my graph. So there's y equals 2. What I'm looking for here is I'm looking for all the points, or any of the points, all of the points that's 3 units away from that line. So looking for all of them in the beginning might be a little bit overwhelming. I'm going to start by just looking for a few of them. There's a point that's 3 units away from that line. Distance from the line to the point, if I count the boxes, 3 boxes. There is a second point that's 3 units away from the line. And a third one that's 3 units away from the line. And right now I'm focusing on those that are 3 units above the line, but I've also got some points that are also 3 units beneath that line. And I'm going to go ahead and graph those also. So I can see my locus starting to take shape here. My locus here in this case isn't one line like it was in the first couple of examples, but the locus in this case is 2 lines. Anybody on either one of those green dashed lines is going to be exactly a distance of 3 units away from the line whose equation is y equals 2. So the equation of this guy is y equals 5. The equation of this guy is y equals -1. So my entire locus consists of those 2 equations. All right, the next one says, what is or are the equations of the locus of points that is equidistant from both axes? So again, it's critical that I involve or begin with my starting point. My starting point in this case is going to be the axes, the x-axis and the y-axis. The points that I'm trying to locate, or the condition that I'm trying to fulfill, are points that are equidistant from both of those axes. So I'm going to go start by finding just one. There's a point that's equidistant from both axes. It's 1 unit away from the y-axis, it's 1 unit away from the x-axis. There's a second point that's equidistant. It's 2 units to the y-axis, 2 units to the x-axis, and so on and so forth. And I could go on and build up a whole set of points that's equidistant from both axes. This guy here at the origin, he's 0 units away, so I guess he would be equidistant as well. And then working this way, I've got a whole new set of points that's also equidistant from both axes. And now that I've got a few points graphed, I can see this locus beginning to take shape. And now I'm all set to go ahead and draw it in here. So there's one set of points that meets the condition of being equidistant from both axes. There's a second set of points that meets a condition of being equidistant from both axes. This guy passes through the y-axis at y equals 0. He has a slope of 1. So his equation is either y equals 1x plus 0 or just y equals x. This fella, same deal, passes through the y-axis at y equals 0. He has a slope of -1, so he's either negative x plus 0 or just plain old negative x. All right, number 5 wants us to graph and state the equation of the locus of points that's 4 units away from the origin. So again, I need to identify my starting point. My starting point in this case is going to be the origin. So just one point. The origin, remember, is the point where the x and the y-axes intersect. My locus is going to be the set of points that are 4 units away from that red dot. So I'm going to go find a point that's 4 units away from the red dot. I'm going to go find another point that's 4 units away from the red dot. And another point that's 4 units away from the red dot. And another one. And this process could go on and on. Sometimes kids are tempted to go put a little dot up here, but that guy is actually more than 4 units away from that red dot, which represents our origin. So be careful. This is actually going to be a curve that goes around. So I'm going to go ahead and take my pen and I'm going to draw in my dotted locus. Think about this as being a circle with a radius of 4, and that's going to be your locus of points. Its equation is going to be x minus 0 quantity squared plus y minus 0 quantity squared equals the radius squared, or in other words, x squared plus y squared equals 16. All right, number 6 is very similar, except it's asking us to graph and state the equation of the locus that's 2 units away from the point whose coordinates are 2, 1. So this is going to be our starting point. That's what we're given to begin with that we're going to work with. We're going to start at the point whose coordinates are 2, 1. This time we're trying to locate the set of points that's exactly 2 units away from that red dot. So again, we've got 2 units in all directions. I want you to think about that as being a circle with a radius of 2. That's not what I wanted. So his equation is going to be x minus 2 quantity squared plus y minus 1 quantity squared equals 2 squared, or equals 4. All right, last one for today. Graph and state the equation of the locus of points that is equidistant from the 2 points with coordinates 2, 1 and 4, 3. So again, I have to identify where it is that I'm starting. What is it that I'm given to work with in the very beginning of this problem? Well, I'm given to work with the point whose coordinates are 2, 1, and the point whose coordinates are 4, 3. So I want to find the set of points that are equidistant from each of those black dots. Well, there's the obvious one. That one is right in the middle. This guy also is going to be 2 units to the black dot on the left, 2 units to the black dot on the right. This guy also going to be 2 units away. So if I think about what this is starting to looks like I'm going to end up with a line. So I'm going to go ahead and put my line in there. And this guy's equation, he bumps into the y-axis at y equals 5. He has a slope of -1, so y equals -x plus 5. One interesting thing to note about this is that he's going to be the perpendicular bisector of the segment that joins those 2 points. All right, so the next time you come to class, we're going to do some practice with these loci that are on the coordinate plane. In the meantime, I want you to remember that as you're doing these, probably the most key thing or the best piece of advice that I can give you to help is always identify what your starting point is first of all. What are you given to work with? Where is it that you're beginning? And then from there, begin to locate points that fulfill the set of conditions or the conditions that are given to you in the problem. All right, if you have any questions, jot them down so that you can remember to ask about them the next time you come to class, and see you then.